Ladies and gentlemen, welcome to the Intelligent Data Center session. This session will focus on Huawei's intelligent data center that offers flexible architecture and innovative technology. Thanks to more than 30 years of expertise in the ICT field, Huawei offers services that cover the entire data center process, ranging from network construction to O&M. At Huawei, we build intelligent, efficient, and green data centers that drive industry digital transformation. Let's first welcome Mr. Zhang Haiping, Director of the Product Portfolio Solutions Sales Department, to discuss Huawei's next-generation data center that will boost industry digital transformation.
Good afternoon, everyone. My name is Peter, and I'm the Director of the Product Portfolio Solutions Sales Department of Huawei Enterprise Business Group. Today, I would like to introduce Huawei's next-generation data center solution that enable intelligent upgrades across the industries. But first, let's look at recent changes in the digital industry. We are now in the fourth industrial revolution, where AI, IoT, 5G, bioengineering, and other intelligence technologies are changing our lives. They are driving sustainable development of society, economic growth, smart city construction, industry upgrade, and improve customers' experience. Intelligence is the key in the fourth industrial revolution, accelerating the digital transformation of society and the major economics and promoting the digital economy. As more industries deepen their digital transformation, there is an explosion in massive data, such as the video and the images. For example, a self-driving car can generate up to 60 terabytes of data center per day. And this data need to be stored for at least 30 years. All industry-leading gene sequencing device can generate up to 6 terabytes of data every day. And this data need to be stored permanently. A smart factory generates about 1 petabyte of data per day. In addition, intelligent oil and gas exploration is going from 2D to 3D, producing 10 times more data. Huawei GRV predicts that in 2025, the world will have generated 180 zettabytes of new data, a 20-fold increase over 10 years. Clearly, going digital produce more and more data, which become the core assets of enterprise. What do we mean by that? We all know that energy resources, such as the oil, the gas, drive the industrial economy. Likewise, data resources promote the digital economy. Data is now even becoming more valuable than oil. Data-driven innovation is gaining power in various fields, such as the economy, society, and R&D, and is a focus of many industries. This is why data is considered the fourth production factor following land, labor, technology, and capital. Data will never generate value by itself. However, with the intelligent technology, we can get unlimited wisdom from data. For example, AI can select only useful information from massive data volumes. It can then provide more efficient decision-making, suggestion, and smart behavior guidance. Clearly, the business value is huge. Data also improve operational efficiency, the quality of life, and the government administration. It also expands the scope of human knowledge. More and more enterprises agree that applying intelligent technology is the next stage of digital transformation. Deepened digital transformation relies on the intelligent to promote decision-making. reshape business model and ecosystems, and redefine customer experience. So the next stage of the digital transformation is an intelligent upgrade. The question is, how can we achieve intelligent upgrade of enterprise to tap into the real value of data? The answer lies in a powerful digital infrastructure. And the key to build such an infrastructure is the data center. First, the data center is the center for storing and processing the data. Huawei has predicted that the proportion of data stored in data center will increase from 53% to 92% in the next few years. Secondly, the AI training needs computing power. So, data centers that deliver massive computing power become the AI training center. In other words, applying AI relies on the data centers, which decide how smart enterprises are. The data center is already the strategic factors for the intelligent upgrade of enterprises, and it is the brain for the enterprise decision making. My next question is, what kind of the data center can better enable intelligent upgrade of the enterprises? As the digital production service moves to the cloud, more data need to be stored. The higher computing power is required, and more energy is consumed in the data center. This brings four major challenges to the data center. Firstly, computing power is insufficient. The AI performance relies on the powerful computing. However, computing power is becoming more costly and insufficient. As a result, just 10% of data is processed in data centers. So we need to focus on how to build a sufficient computing power for the digital economy. Data access is the second challenge. If we look at the data generated worldwide, the cost of the data storage is still higher. Currently, less than 2% of data is finally stored, and a lot of low-value data is discarded. Due to the poor storage performance, even some higher-value data that is stored cannot be fully utilized. After digital production services go to the cloud, they require high network reliability. The threats such as the natural disaster and the cyber attacks are everywhere. To overcome those threats, the data center needs to properly implement disaster recovery, which we call DR. So the third challenge is, what kind of DR center can ensure the zero data loss and avoid service interruption? The final challenge is higher power consumption of data center. If we look long term, the power consumption of data center requires more than 50% of the total cost of ownership. Also, data center is getting large. Globally, data center account for 50% of the power consumption of the entire digital ecosystems. So achieving the net zero carbon emission requires data center to consume less power. So building a green data center is of vital importance. Huawei has made many efforts to overcome those four challenges. For example, by leveraging expertise in full-stack products, we carry out joint innovation across the products and launch the next generation data center architecture. If we consider the current data center as the brain for the enterprise decision making, our next generation data center is a super brain for intelligent upgrade of the industries. Huawei's next generation data center solution have several highlights. First, it can provide lossless computing power to boost the digital world. Second, its all-flash storage fully unleashes value of data. Third, it delivers active reliability, ensure always-on services. Finally, it requires less power to helping our customer to achieve net zero carbon emission. Now, let's take a look at how Huawei achieves this through cross-product joint innovation. Computing power is the engine of the digital world. To obtain more computing power, we either use higher performance servers or add more servers. However, adding more servers will not always increase computing power. This is because more servers may cause network congestion and packet loss, which reduce the computing power. The test results show that the computing power is reduced by 50% if the packet loss rate is just 0.2%. The more clusters lead to more packet loss, limiting the computing power. To resolve these issues, Huawei provides higher performance fusion server and the industry's only intelligent lossless data center switches. We call it Cloud Engine. Data is valuable only when it flows, and the storage performance affects how efficiently the data flow. In 2020, Huawei broke through the upper limit for storage performance once again. Huawei's next generation Ocean Store Dorado all-flash storage achieved 20 million RPS. How can Huawei develop such advanced devices? The answer is twofold. First, Huawei has been committed to all-flash for many years. Second, Huawei enables connectivity between the storage system and front-to-end application servers. In addition, in the traditional storage systems, dedicated fiber channel is used for the connectivity. This delivers poor storage performance due to the limited bandwidth. To overcome this, Huawei used NVMe-based Rocky SAM. This technology used ultra-broadband Ethernet to fully unleash all-flash performance. This helps to reduce the end-to-end latency to less than 50 microseconds, the lowest in the industry. Data centers now carry many production services, such as the finance services. These services require zero packet loss and zero service interruption. The traditional data centers cannot meet these requirements as they perform active standby switchover upon faults. Huawei overcomes this by integration storage, switching, and WDM technology. In this way, the end-to-end latency is less than 1 millisecond, and the active service transmission reaches 70 kilometers to ensure 24/7 always-on services. Additionally, intra-city active traffic keeps increasing with the service growth. Traditionally, 8 GE or 16 GE fiber channel connectivity is used, which is waste a lot of optical fiber. So Huawei replaced the traditional fiber channel network with the 100 GE Ethernet to reduce the link data by 90%. This helped achieve lossless Ethernet transmission over long distance. Finally, let's look at Huawei's latest innovation in the energy saving and the emission reduction for data centers. The IT devices, such as the computing, the storage, the network devices, account for more than 50% of the total power consumption of the data center. However, we cannot stop IT devices from the consuming power. So Huawei integrated many energy-saving technology into the IT devices, developed and designed to avoid unnecessary waste. These technologies include computing hibernation, system hibernation, and dynamic power management. The remaining 50% of power consumption in data center is caused by cooling, heat dissipation, and the power supply. This is also called PUE. Huawei used eye-cooling technology to perform end-to-end energy efficiency management at the system level. reducing the PUE by 5 to 8% to less than 1.2. Now, let's look at the typical data center with the 100 cabinets. With the eye-cooling technology, about 4.54 million kilowatt hours can be saved each year. This is equivalent to planting 145,000 trees. This takes us closer to the building across a lower carbon intelligent digital world and achieve net zero carbon emission. Lossless computing, all-flash storage, and intelligent energy saving are the highlights of Huawei next-generation data center architecture. Thanks to cross-product joint innovation, this architecture comprehensively addresses the 4 challenges faced by data center in the digital economy. Build the super brain for the intelligent upgrade across the industry, and fully unleash the data center potential. In the next stage, I will invite my colleagues to introduce the detailed solution to you. Thank you.
Thanks, Mr. Zhang, for your insightful thoughts on how the next generation data center will support digital transformation across industries. Next, let's look at the key components needed to build a future-proof data center. Rapidly growing services and data volumes brought by industry digital transformation will impact the storage system. The question is, how can enterprises build a green, reliable, and intelligent storage system to release the real value of data? To answer this question, Ms. Amy Liang, Vice President of Enterprise Data Storage Technical Sales Department, will share her thoughts on the topic, moving towards an all-flash-powered data center. Let's welcome Ms. Liang.
Ladies and gentlemen, I'm Amy Liang. Today, it's my great honor to share with you of the next topic, moving towards an all-flash-powered data center. As we can easily judge, the world is fast diving into a fully digitalized era. In the past 10 years, the whole data amount has increased several times. And with the explosive growth of internet traffic, in next 5 years, the amount of data to be stored will increase from 32 zettabytes to 180 zettabytes by the year 2025, among which the unstructured data will account for more than 80%. Like in the agricultural economy age, the land and labor were the primary production factors. In the industrial economy age, capital and technology became important factors of production. Now, with the advent of the digital economy, data is a core means of production. Take digital interconnected factories as an example. The data volume is easily increased to PB level, and to develop one model of self-driving car, at least 64 terabytes daily training data will be generated per day. The data explosion drives the maturity of the data volume chain and further drives enterprise decision-making and innovation to generate digital dividends. Thus, we need powerful digital infrastructure to capitalize on data during this transformation. Most of the data infrastructure are installed in data centers, like servers for computing, switches for data exchange, and storage for data reservation. In light of explosive data growth, diverse data types, and the ever-increasing importance of it, data centers face the following challenges. First, the service pressure becomes higher and higher. The digital transformation of enterprises drives huge amounts of offline services to go online, and innovative services are emerging one after another. Online and diversified services result in more than 10 times of peak loads, which requires high reliability. This is amplified by the finance sector, especially due to the e-commerce and mobile payment. During peak hours in China's Double 11 shopping festival, the transactions per second of a large bank increases from 3,000 to 30,000. Second, with the data volume and application increase, data centers are getting larger, and the total amount of small and edge data center grows. Data centers have become a major power consumer. Currently, the total global power consumption of data centers costs around 2 to 3% of the annual world power consumption. And the power consumption will reach 42% of the total ICT consumption by 2025. High energy consumption results in high electricity costs. In fact, electricity costs account for 60% of the total TCO of a data center during its 10-year life cycle. Another consequence to consider is the high carbon emissions. The global carbon emission of data centers are equivalent to those of the aviation industry and account for 60% of the total energy consumed by the digital ecosystem. According to the United Nations Environment Programme, global emissions must fall by 7.6% per year for the next decade to meet the 1.5 degrees centigrade goal. The European Union is committed to achieve zero carbon emission by 2015. There is still a long way to go for data centers to save energy and reduce emissions. Third, as data becomes more and more important, data center shutdown becomes unacceptable. Statistics show that nearly 1 million enterprises go bankrupt every year due to data loss. And the loss caused by downtime in the financial industry reaches up to 6.48 million per hour. 4. There are also other costs to consider. A data center with 1,000 racks usually has over 100 types of device, and information about dumb devices is not transparent, which increases the difficulty in fault location and related service response. Due to a large number of vendors and interface, the training cost of operation and maintenance personnel are high. As a result, 61% of data centers lack qualified O&M personnel. By 2025, the amount of data maintained per capita will increase fivefold, which further increases the difficulty of O&M and labor costs. All the challenges will require an upgrade on data center technology, not only of the media, but also the integration of data center resources and reconstruction of the architecture in order to meet diverse future service requirements. Specifically, the all-flash data center solution covers all-flash upgrade for the whole IT infrastructure, flash-based servers, NVMe native all-IP data center network, all-scenario all-flash storage, and full lifecycle intelligent O&M for multiple data workloads. For storage ledger, the upgrade has 3 key characteristics: all-scenario flash, full series high-end quality, and all-scenario data protection. It helps build a greener data center with higher efficiency and availability, more intelligent O&M, lower TCO, and zero network bottleneck. All scenario flash have 2 meanings. The first is that diverse types of data are willing to be stored in flash media-based system. Not only the data from enterprise mission-critical applications, but also those data from edge, HPC, big data, and other systems. The second is that from primary storage to secondary storage, like backup appliance, HDDs should be replaced by SSDs to enhance the performance while reduce the cost and power consumption. All scenario flash delivers 2 benefits: cost reduction and efficiency improvement. Offering the same capacity, SSDs reduce power consumption by 70% and space by 50% than SAS HDDs. This slashes the TCO of data centers and helps them to go carbon neutral. In terms of procurement costs, IDC statistics show the unit price of SSD is now lower than SAS HDD by introduction of deduplication and compression functions in storage system. So we already see the SSD shipment proportions increases year on year, and replacing HDDs has become an inevitable trend in primary storage scenarios. And from 2020 to the next 5 years, along with the usage of several types of new low-cost media like QLC-NAT, the secondary storage will also change to flash-based. Here we got an example. A bank changed their total 10 cabinets of storage to 4 cabinets of flash storage. The performance increased by 150%, saves 60% of space and power, and 50% of manpower since all the technology are similar from no big difference between systems. Well, all scenario flash transformation also requires high-end quality for both high-end storage and mid-range storage. Take banking industry service as an example. Traditional core services include payment and transfer, daily settlement and monthly settlement, card issuing, and wealth management. Such data requires over 6 nines availability, million level IOPS at a latency of sub-millisecond per device, as well as both high scale-out and scale-up capabilities. With the advent of the Bank 4.0 era, the friction-free model developed intermediate business and intelligent services blur the boundaries between core and non-core services. Fast mobile payment and ubiquitous financial services drive higher service processing requirements. Take a typical medium-sized bank as an example. The bank requires 24/7 service continuity. It has seen a 10-fold increase in transaction frequency and a 40-fold increase in daily data volume, from 50 gigabyte to 2,000 gigabyte. So here's the conclusion. Facing the uncertain, fast-changing future, even mid-range storage needs to offer high-end quality to address higher service demands. Now, let's look at the comprehensive data protection solution. It has 3 aspects. Disaster recovery mechanism to create an active or passive full copy for the source data. Backup mechanism to create several time-based copies for the source data. And archive mechanism to move source data to a longer retention media and make copies to protect it. In short, when building an all-flash data center, those 3 mechanisms should be considered. There's a challenge leads to cost efficiency, faster solution. During the last decades, data is more and more used for mining and big data analysis. The life cycle of data stay in the main storage system is prolonged, and the volume of data retention and protection is enlarged according to the demand. But the time window and budget for data protection didn't change or become even less. By introducing local active-passive function to replication to the cloud, the system availability improved. By adding flash disk into backup storage and improve the data reduction ratio, the huge amount of data is able to be fast backup within a certain time window at low cost. Traditionally, in the data center, fiber channel network is the last specialized network used dedicated for connection between server and storage. Now, all scenario flash is driving the storage media interface transform from SCAS to NVMe, which calls for a faster, reliable network. Currently, normal fiber channel network speed is 32 gigabit per second and 64 gigabit per second. Comparing with Rocky network 25G, 15G, 100G, it is theoretically much slower and not able to unleash the power of flash storage. That brings us to NVMe over Rocky storage network. NVMe over Rocky is an easy-to-manage model that uses IP network to provide 10 times higher throughput and lower latency than fiber channel. The NVMe over Rocky solution is the best solution for implementing an end-to-end NVMe storage network. An all-flash data center should have full lifecycle intelligent O&M capabilities. That is, automatic and intelligent capabilities are available in all phases of planning, provisioning, O&M, and optimization. Intelligence and big data technologies are key to improve data center management. In the planning phase, resources are preciously planned, and the focus has shifted from device upgrade to full lifecycle data management. In the provisioning phase, global resources are automatically provisioned. In the O&M phase, full-stack intelligent O&M is implemented to change reactive inspections to proactive discovery. In the optimization phase, agile configuration optimization and automatic resource prediction and change are implemented. The optimization is performed using intelligent algorithms instead of expert experience. Today, we are glad to bring you the Huawei all-flash powered data center solution, which is business-enabling, green, reliable, and intelligent. The solution consists of OceanStor all-flash storage series as primary storage, Ocean Protect series as data protection secondary storage, NVMe over Rocky storage network either from Huawei or other vendors, and DME full lifecycle intelligent O&M. Huawei OceanStor all-flash storage is very suitable for serving the core application systems in a wide range of industries like finance, carrier, medical care, and manufacturing. It delivers industry's highest 7 nines reliability. The storage tolerance failures of 7 out of 8 controllers and the failure of a single controller enclosure without service interruption. Moreover, SSDs yield at 5 years return rate of just 0.8%, which is 10 times lower than HDDs. When it comes to performance, the OceanStor all-flash storage delivers the industry record 21 million IOPS under typical frequent used I/O patterns. The performance with various features enabled has only less than 10% impaction. For example, when data reduction, garbage collection, read-seeks, and snapshot are enabled, the performance of our storage decreases by only about 10% and remains stable. In contrast, the industry average performance of other vendors' storage decreased by 40%. In terms of availability, the OceanStor all-flash storage provides 100% data availability guarantee and flash-ever hardware subscription model to the customer to protect the customer's invest. Huawei Ocean Protect provides customers with all-scenario data protection. We provide a comprehensive solution that protects data throughout its lifecycle, from data generation, use, to destruction. The overall solution that includes disaster recovery and backup helps our customer achieve disaster recovery of production data, backup of critical enterprise data, and valuable data reuse. Huawei Storage provides various disaster recovery features, such as active-active, active-passive, and 3DC solutions, and uses OceanStor BC Manager for unified, intelligent and simplified disaster recovery scheduling and O&M management. In the backup scenario, we provide both centralized backup solution and all-in-one backup appliance to allow customers to collectively or separately deploy backup storage and media to meet different customer needs. We fully understand the main purpose of backup is to recover the data when needed. Our Ocean Protect backup appliance has the fastest speed among all the vendors. And we are working on helping the customer reuse the backup data directly from the backup appliance for like test and validation scenarios. As I mentioned in the previous slide, the trend of storage network now is changing from FC only to NVMe over Fabric. And IP-based storage network has big advantages on both speed and cost. However, the IP network often encounters packet loss. When SSDs are used in the IP network, the storage IOPS increases and the Ethernet network pressure grows, causing the packet loss rate and the network latency to surge. To address this issue, Huawei intelligent IP switches use an innovative lossless algorithm to dynamically adjust the threshold, greatly reduce packet loss and ensuring consistent low latency of the storage network. The all-IP NVMe over Rocky network reduced the average latency by 42% compared with the fiber channel network, achieving an end-to-end latency of less than 50 microseconds and 30% higher IOPS. Huawei introduces Data Management Engine, or DME, to ensure automated management throughout the data lifecycle. It automatically collects the running status of all devices to ensure end-to-end storage network awareness. It also predicts and warns about faults to help prevent disasters, and can intelligently analyze information to rapidly locate the root causes of faults. Last but not least, it provides expert suggestions to help users to optimize their systems and achieve end-to-end automated, trusted execution. It's time to choose a fully future-oriented, all-flash-based solution for your data center construction plan. Huawei in this industry is quite highly recognized. Not only garnered the Best of Show Award grand prize at Interop and was recommended as the leading position among global top 5 by DCIG, but has also been listed as a leader by Gartner for 5 years consecutively. We maintain strong growth in the global market, has been chosen by the most customers in China since 2018. We are now serving over 12,000 customers all around the world. Hope that we can have the chance to cooperate in this area. Thank you.
Thanks, Ms. Liang. High-performance computing underpins most industries and is becoming more and more important for decision makers. On top of this, a variety of technologies are using AI and high-performance data analytics. Against this backdrop, we invite Mr. Lu Dejian, Chief Expert in the mass data storage domain, to talk about how next-generation storage accelerates HPC evolution. Let's welcome Mr. Lu.
Hello, everyone. I'm Lu Dejian from Huawei Mass Data Storage Domain. As we all know, more and more HPC applications are using AI and big data technologies to improve efficiency. We know that data plays a critical role, whether AI, big data, or HPC. So storage is becoming more and more important in HPC. What role does storage play? I'd like to share some of my insights to answer this question. It's no secret that HPC is playing a critical role in our society. It has become an important driving force for social progress. For example, we can use HPC to accelerate drug screening and molecular analytics, greatly shortening the R&D period of new drugs. When it comes to automotive industry, HPC helps implement autonomous driving simulation by using data to simulate for diversified scenarios. This greatly reduces cost and time of development. Another example is from genome sequencing. It took 13 years to fully complete the whole genome sequencing at the beginning. But with the help of HPC, we have shortened the time to just 1 day. Remarkable, right? In weather forecast, with HPC, we have a strong feeling that the forecast accuracy is much better than what it was 10 years ago. In recent years, HPC has become even more closely integrated with big data and AI. Data is becoming more important to HPC. This has promoted the HPC industry to evolve from computing intensive to data intensive. Let's take a look at the HPC market growth rate on the right. It shows that the data-intensive HPC markets are growing much faster than traditional HPC. Now, let's look at 3 major challenges faced by the HPC industry. The first challenge arises from massive data generated by new technologies and emerging workloads. For example, an autonomous driving test vehicle can generate up to 60 terabytes of data every day. This data must be stored for at least 30 years. The most advanced sequencer can generate 6 terabytes of data each day, which need to be stored forever. In the oil and gas exploration industry, compared with 2 dimensions, 3 dimensions generate over 10 times more data. Ever-growing data volumes will bring big challenges to HPC infrastructure with higher TCO, such as procurement cost, data lifecycle management, rack space, and power consumption. The second challenge comes from hybrid workloads. For traditional applications, they often involve multiple processing phases. These phases usually have a different I/O behaviors. I'll take oil and gas exploration as an example. Seismic data processing requires high bandwidth, while seismic data interpretation needs high OPS. Generally, 2 different storage systems are required to host these 2 types of workloads. As for emerging application, they cause explosive growth in diversified computing, such as GPU, NPU, and FPGA. This further increases the challenges of diversified workloads. The diversity of data access method is another challenge. Let's take autonomous driving as an example. The development process involves multiple phases, such as data import, data pre-processing, model training, and simulation. There are diversified data access protocol interfaces being used in those phases, so time-consuming data migration cannot be avoided. But time is very important to the end-to-end development process. We heard a lot of complaints from our customers for this situation. To sum up, we believe that increased data analysis requirement in the HPC industry create 3 main challenges for storage. First, enterprises find more and more value in massive data. They are willing to store more data for a much longer period. This causes the data volume to grow from petabyte to exabyte level. Consequently, they need a storage system with higher scalability and lower TCO. Second, diversified computing leads to more complex workloads. This requires one storage system to support different types of workloads. Finally, HPDA requires efficient data access in multi-phases, so the same data can be accessed over different protocols without migration. Thanks to continuous investment in HPC, we have built a full-stack infrastructure solution. We focus on development of basic hardware platform, software platform, and professional services. By working with our industry partners, we offer a variety of professional solutions for customers across multi-industries. Storage is an important component for our full-stack HPC solution. With extensive know-how in storage, we aim to unlock HPC potential with extraordinary storage power for a variety of customers. In the past years, we have developed a storage product for different HPC scenarios, such as the OceanStor 9000 series for distributed file system, Fusion Storage for big data. The OceanStor Pacific series we are introducing today is the next generation high-performance storage. It can help customers address new challenges arising from the HPC evolution. It has 3 key features. The first is its high-density design, which increases the capacity and the performance densities to minimize the footprint and TCO. The second feature is that the storage is oriented to hybrid workload for higher performance in all scenarios. And the third is the multi-protocol interworking feature that supports the evolution from HPC to HPDA. Let's take a closer look at how we use these innovations in typical scenarios. First, in scientific research, such as genetic research, genome sequencing generates a huge amount of hot data, which requires extremely high storage performance. After sequencing is complete, cold data need to be carved to an economy storage. Our next generation storage, the OceanStor Pacific, can easily deliver a storage solution for these requirements with optimal TCO. First, compared with general-purpose hardware, the high-density hardware design can reduce cost by over 20%. The OceanStor Pacific 9950 is a high-density performance model. It can provide a bandwidth of 32 GB per second per unit space, delivering excellent performance to deal with massive data. The OceanStor Pacific 9550 is a high-density capacity model. It provides 1.6 petabyte raw capacity in a 5-unit space, which is 2.7 times the capacity density of a traditional high-density server. Second, based on the configured policy, the data tiering feature efficiently and automatically migrates data between a high-density performance pool and a high-density capacity pool without manual interaction. Next, let's look at the oil and gas exploration scenario. As we know, seismic data processing requires high bandwidth, while seismic data interpretation requires high OPS. Traditionally, 2 storage systems need to be deployed to meet the requirement separately. To tackle bandwidth-intensive and OPS-intensive hybrid workloads, we launched OceanFS, which is the next-generation power file system delivering both high bandwidth and high OPS. First, OceanFS distributes metadata on multi-nodes to eliminate the distributed locking overhead. This can reduce the latency by 15%. Second, large and small IOs are separately processed to decrease resource contention. This can reduce the overall overhead by 60%. Third, the dynamic disk indexing technique prevents I/O amplification, reducing the latency about 30%. With these features, OceanFS enables one storage system to fully meet the needs of multiple phases. Finally, let's look at how manufacturing simulation benefits from multi-protocol interworking. In SPDA scenarios, such as autonomous driving development, there may be different data services to be used in phases of pipeline, such as file, object, and HDFS. Traditionally, these three services are separately provided by three storage, meaning data needs to be copied multiple times between devices, causing lots of wasting on time and resource. In contrast, the multi-protocol interworking capability of the OceanStorm Pacific allows one data copy to be shared with multiple protocols. And all data service interfaces are native. The native interface design achieves zero loss of semantics and performance. With the OceanStorm Pacific, we can shorten end-to-end simulation process, reduce the time to market our product. Now, let's review the three major HPC scenarios of the OceanStorm Pacific. In scientific research field, we are always trying to help our customers to reduce TCO. We use a high-density design to reduce both CapEx and OpEx of HPC environment. In oil and gas exploration field, the hybrid workload-oriented design enables one storage system to handle the data produced in multiple phases. It simplifies the management of HPC infrastructure. In manufacturing simulation field, the OceanStorm Pacific can provide file, HDFS, and object service interfaces in one storage. So no data migration is needed. We can shorten end-to-end simulation process, reduce the time to market a product. Huawei will continue to provide our customers most valuable storage solution and working with industry partners for faster and smooth evolution of HPC. That's all. Thank you.
Thank you, Mr. Liu.